We're going to look at some acid-base chemistry in this video. We're going to look at how to name and some properties. So let's start off with what an acid is. So acids are solutions that, firstly, they taste sour, like a lot of types of fruits out there. Think of the kind of face you would make if it were something sour as well. Additionally, they burn when touched. My picture here is if you had a cut on your finger and you were peeling this orange or even a grapefruit and you got some the juice in your finger, it would probably burn. Or if you just generally touch something and it burned, perhaps could be acidic. And lastly, what happens is acids will turn blue litmus paper red. So in chemistry, there are two types of paper strips. One's blue, one's red. And when you dip them into an acid, they will both go red, kinda like that. So that little experiment will prove that the solution is acidic. So to talk specifically about compounds that are acids, acids have or start with a hydrogen. In this case, I've written compounds that contain an H plus ion. So essentially, compounds that start with hydrogen. And there are two types of acids. The first type is called a binary acid. So what two things make up a binary acid are, firstly, they contain an H plus ion, and secondly, they are bonding with a nonmetal. So example here is if you add hydrogen and you put it with chlorine. For us to figure out our formula, we're just going to simply cross over the charges. You get a 1 there, you get a 1 there, and your formula would be HCl. If you wanted to go ahead and name this one, you would call it hydrochloric acid. And the part I'm underlining here, the hydroic acid, that's the part that always remains. So if you want to change to a different element, like bromine, you would just remove the chloric part and put bromic. I do have some examples here of some common acids. So here's the one we just looked at, hydrochloric acid. HF is hydrofluoric acid. H2S is hydrosulfuric acid. Hydrobromic acid, hydrophosphoric acid, and hydroiodic acid. So all of those start with hydro. The binary acids start with hydro. I think pretty much if you can remember the first one, HCl, because that's a common one, and its name, hydrochloric acid, you should be able to kind of figure out the rest of them. So our second type of acid would be an oxyacid, and the two things that make up an oxyacid are again that H plus ion, and this time any of our polyatomics. So for example here, if we took H plus and we put it with our sulfate, our SO4, again we're going to cross our charges over, so this 2 will come down and it's going to make us have 2 hydrogens in our formula, and the 1 will come down here and it will make us just have 1 SO4. So H2SO4. Again, that 2 came from the crossing over. You want to name this one, it's just called sulfuric acid. It's all we've done is we've dropped the word hydro. So if we're doing a polyatomic, there's no hydro. And here are some examples here. We didn't really, acetic acid may be just a little more difficult because of the acetic acid molecule. We haven't looked too much at it, but the rest of these should be pretty straightforward here. So HNO3 is nitric acid, H2CO3 is carbonic acid, sulfuric acid, and phosphoric acid. Again, you'll notice that it was just these polyatomics that were crossed over. Bases. So some properties of bases are they taste bitter. So think about the bitter face being made. They are slippery when touched. And lastly, they turn red litmus blue. So in the experiment here, you can see that a base is being applied to both pieces of pH paper, and they're both going blue. Blue for base. So blue, base, don't forget about that, bitter. So the feature of a base is a compound that ends with an OH molecule. So that's a hydroxide. So you can take any old metal you want, put it with the OH molecule, do your little crossover, and you get your formula. And then we're just going to name these just like any other ionic compound. So this one is sodium hydroxide. And here are 6 other bases. So you'll notice that we've got a couple bases down here where we need a bracket around the OH, and that's because each of these metals had charges of +2. So that 2 came down and resulted in that part.